Good day guys, so we are tasked to discuss the lesson 13, which is the topic of forces of friction. So let me start with this question. What is friction? Friction is the force that resists the motion of two surfaces moving past one another. An object on a surface or through a viscous medium such as air or water encounters resistance as it interacts with its surroundings. The resistance is called friction. Forces of friction are essentials in our daily lives. Friction makes it possible to grip and hold things, drive a car, walk, and run. Even standing in one spot would be impossible without friction, as the slightest shift would instantly cause you to slip and fall. There are different types of friction. One of it is the static friction. Static friction is the friction that resists the motion of two stationary surfaces past one another. Static friction resists the onset of motion. A second type of friction is known as kinetic friction. Kinetic friction force is the friction force that resists the sliding of two moving surfaces past one another. And this animation demonstrates properly and how static and kinetic friction differ from each other. There are factors that affect friction. There are two. First is the force with which the two surfaces are pressed together, also known as the normal force. The second factor that affects friction is the nature of the two surfaces are sliding across each other, represented by a number known as the coefficient of friction or mu. The value of mu depends on the actual materials that are pressing against one another. Now, let's talk about why increasing normal force increases the force of friction. When two surfaces are pressed together with a normal force, the amount of contact between the surfaces at the microscopic scale increases. Increasing normal force increases the contact, and in turn, increases the friction force. So let's proceed to the second factor that affects friction, which is the coefficient of friction. Every combination of surfaces has its own unique value for the coefficient of friction. The coefficients of kinetic friction are lower than the coefficients of static friction.
Now, let's proceed to the mathematics of friction, and that means formulas. The two variables that affect friction will start with the formula of kinetic friction. As you can see, it listed here, the force of kinetic friction is equal to the coefficient of kinetic friction multiplied by the normal force. The coefficient of kinetic friction depends upon the materials that usually given or in activities. The normal force refers to how much force the two surfaces are pressed together. Here's the formula for static friction. It looks the same to the other one except there's a less than or equal symbol is indicated in static friction. And that is mean static friction has an upper limit when exceed the object begins to move. This image can illustrate the idea of static friction upper limit. Let's suppose that we push on a brake, and as we increase the force up on the brake, it doesn't move. And that's because the static friction forces balances it push with 10 newtons of applied force, you get 10 newtons of friction force. When you push 20 newtons of applied force, you also get 20 newtons of friction force. Push 30 newtons of applied force, you get 30 newtons of static friction force. But there's an upper limit such that if you push with 37 newtons of applied force, static friction can hold the brake in place and you begin to exceed it. So the static friction force is anywhere from 0 up to 37 newtons, but it can't be any greater than, and once you exceed the force, the upper limit, the brake begins to move and the kinetic friction becomes the friction's force.
Now let's use their formulas. Here's a kinetic function problem. The coefficient of kinetic friction between an 86 kg disc and the wood floor is 0.38. What force must be applied to move the disc at a constant speed? The phrase constant speed is important. It implies a balance of forces, so the gravity force and the normal force must balance each other. Somebody is pushing on the disc in that applied force is balanced by the friction force. With the balance of forces, what we know is the forward applied force is equal to the force of kinetic friction. Now, because the force of kinetic friction is equal to mu times normal force, we can state that the kinetic friction force is also equal to mu times mg. If
We solve for milligram for this 86 kilogram desk. We get a value of 842.8 newtons. So we can now say F is equal to 0.38 times 842.8 newtons, and that comes out to be about 320 newtons. That's the applied force that balances out the friction force. Now, let's try a static friction problem. The coefficient of static friction between an 86 kilogram desk and the floor is 0.45. What force must be applied to the desk to get it started moving? So, one more will assume that the synthesis desk is at rest, the forces balance each other. So, in the static situation, the applied force is equal to the friction force again, and the normal force is equal to the force of gravity. So, if we do the solution, we have to begin with the idea that the applied force equals static friction force, and the static friction force is given with the formula mu static, that's 0.45 multiplied by the normal force. But since the vertical force is balanced, the normal force is equal to the gravity, which is equal to m times g. For an 86 kilogram disc, the force of gravity is 842 newtons. That's also the normal force. So how we say force of friction is equal to 0.45 times 842.8 newtons. That gives us the force of friction. That's 379 newtons. As the force of friction, the applied force must be a hair greater than 375 newtons, like 379.001 newtons, and that's how you handle the static friction situation. So here are some problems and solutions that suits for this topic.